Okay, so Ben, I know you got the first one. E is F over Q. Okay, and in the exam you need to say that E is the electric field strength. F is the force on the charge. And then Q is the charge. Okay? And and you can say it in words as well, correct. E is defined as the force F experienced by a particle per unit charge. Yeah, that's all fine too. That's all good, many ways. Right, what happens if the Q is halved? Well, if the Q is halved, what happens? What is the effect on each of these? Well, if I halve the Q, this E doubles.
Sorry, I don't know. I didn't the idea.
You have
I think the charge half.
Ah. No. And then there's no there's
Still with
no. You can no, I'm sorry, that's wrong. Hang on. I'm very sorry. So if the Q is halved, then the F must be halved as well, because the E is constant. So the F is also halved as E is constant. Yeah? Yeah? Continue? Okay. Right. What is the electric field strength? So you have the formula, I think Ben, you had it too. It's equal to KQ over R squared. Whereas Q is 2.5 times 10 to the minus 3. And R is 0.025. So Ben, do you have this E here? K is 8.99 times 10 to the 9. K is at the start of the book, look.
So I think it's 3.
Here's K. 8.99 times 10 to the 9, that's K.
I think it's 3.6 times 10.
Say again?
3.6 times 10.
Okay. Next. So, this is a positive charge, and it makes an electric field. And here you now have a negative charge. So what will happen to the negative charge? It will be pulled in, won't it? Yeah? So the F is towards the plus, with value equal to QE, which is 1.5 times 10 to the minus 3 times 3.6 times 10 to the 10. What's that?
Minus 5.40 times 10 to the 7.
Yeah?
So it's minus.
Well, I don't need the minus because I already have the direction when I said this. If 2.5 are added to each charge, describe what would happen to the magnitude and direction of the force on charge B. So if you add 2.5, then A becomes 5 and B becomes 1. Right? Yeah. Yeah. So the question now is again, what's the force and direction? They're both positive. So what happens now is B is pushed away. Yeah? Goes like this now. By A. Yeah. And the force is K, Q1, Q2 over R squared. That's 8.99 times 10 to the 9 times 5 times 10 to the minus 6 over 0.025 squared.
The same Q.
Yeah. No, different. 1 and 5 now. They've changed.
Huh? I mean the K.
K, same K. Yeah.
Yeah, I mean it's the same K.
Yes, not Q. You have the number typed in, Khalifa? So again? Next, sketch the field lines and 3 potential lines around a point negative charge. Right, so there's the negative charge. They're the field lines, and then the potential lines are like this. They're the potential lines. Okay, that's okay for 3 marks, I think. Okay, C. So, a particle of charge 3.2 times 10 to the 19 is projected at that into a uniform magnetic field. Okay, so you have a magnetic field. Of 35 millitesla. And you have the particle that goes in, and its charge is 3.2 times 10 to the minus 19 coulombs, and its speed is 2.8 times 10 to the 5 meters per second. First question, what's the force? Oh, and it goes in, and then this is positive. Okay, so I think it goes down. Curves around like this. Anyways, the first question is what is the force? And the force is QVB, which will be 3.2 times 10 to the minus 19 times 2.8 times 10 to the 5 times 35 times 10 to the minus 3.
4 times 10 minus 50.
Okay, next. What's the acceleration? So A equals F over M, 3.14 times 10 to the minus 15 over M, 3.34 times 10 to the minus 27. What is that?
Wait a second. What's, oh, it's A and 10. Okay.
Yes, I.
Nine times 4, 11 times 10 to the 11.
Okay, next they want you to calculate this radius. Yeah? Good news for you, good news. If you look at the formula book, where is it? Oh, sometimes they have it in the book and sometimes they don't have it. No. Those guys. What jerks. I don't see it. Sometimes they have it, sometimes they don't. Okay. There's a formula, but we'll have to calculate the formula. So, anyways, it's not so difficult because you can say F equals M omega squared R, isn't it? So mv squared over R, that's that. You can also say F equals QVB. Yes?
Yeah.
So, if you make these equal, yeah, you can cancel the V's and you get mv over R equals QB. So R equals mv over QB. Now sometimes they have that formula in the book, sometimes they don't have it in the book, I don't know why. So R equals M times B, times V over Q times B.
It's 3.5.
No, 35. Okay. And lastly, you want the radius to be half. What should you do to the magnetic field? So if you want this to be half, then what do you do to B?
Double.
Double, very good. Okay. Okay. Next question now. Waves. I think waves. Oh, come on, you must be. You can't forget everything. Can't forget fields and waves.
I can.
Right, 20 marks, 20 minutes, off you go.
Oh, it looks like the how to say the can something.
The seesaw. Up, down, up, down.
No, I mean it's like the way, the wall and
Oh, cantilever.
cantilever.
Yeah. It's not cantilever.
Yeah, yeah.
It's just a string.
This thing. What?
Yeah.
This way?
No. This is a string.
Yeah.
You know, music. You pull the string.